Thank you for coming over here. Dear students, I am Dr. Jebaraj, giving you some ideas in the analytical geometry. Okay. Mainly we are going to study about sphere, straight line, cone and cylinder, those equations and those pictures, and also some properties and some problems we are going to do in this class. It will go nearly 1 hour, so you have to sit and listen to me what I say. I am telling some basic ideas, also deeply about and the comparative study also we are going to do today. So let me start my teaching now. And now this is what we are going to discuss today: the sphere and some cone and cylinder and also straight line. Okay, different types of straight line equations we are going to study. Okay, so let me discuss about those things. First of all, let me take sphere. I am going to take now sphere. Okay, right. For that I have to minimize, and I will take this equations. Of course, what is this? Now look at that. This is what a sphere we say. Okay, so sphere, that's what we are going to do. Afterwards we are going to study about the straight line, and then afterwards symmetrical form. So many forms are there in straight line, am I correct? Then afterwards we are going to study the cone equation, then at last with the cylindrical equations. These are what we are going to discuss. First let us talk about we will talk about this sphere. Okay, so now what is a sphere? Okay, so sphere is nothing but, you look at that picture there, and this is what we say a sphere. Okay, so this is like, okay, here, and this is the center point in the three-dimensional space. A comma B comma C is the point, center point, and this is what the moving point, that is a surface points. Okay, this is looking like a circle, but it's not a circle. You must note that it is not a circle, but it is like a sphere. That's what you have to understand. It's looking like a sphere like this. Okay, now it is looking like a sphere, am I correct? Okay, now this is what we say a sphere. This is the center point. These are all the points on the surfaces. Okay, suppose that from the center point all these points are in the equal distance from the center, and that equal distance we are taking as r. R is the equal distance. Okay, from this center point to all other surface points. Okay, then from the geometry we know that x minus a the whole square plus y minus b the whole square plus z minus c the whole square must be equal to r. I think it is not r, it should be a r square. Okay, it must to be an r square. Right, now this is what we say a sphere. Okay, if you expand this by using the formula, square formula, you will get and simplify, you will get this equation: x square plus y square plus z square minus 2ax minus 2by minus 2cz plus a square plus b square plus c square minus r square equals 0. That's what the equation for this particular sphere, where center is a comma b comma c and the surface points are x comma y comma z, and the constant distance is r, then this is what the equation of a sphere. Okay, but what's a general equation? Okay, the general equation of the sphere, now look at this. Yes, you can see on the screen here, this is a general equation of a sphere. There is a particular equation. Okay, we have seen this just before. That is a particular case. Okay, so this is what a particular case, but the general case is this. This is a general equation of a sphere. Okay, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals 0. So one thing I do want to say is that the set of all the points such that set of all the points x comma y comma z which satisfy this particular equation will be the points on these surfaces. That's what you have to understand. Okay, so what you have to understand is that the set of all the points, or set of, I can take here this ink. Now set of all the points x comma y comma z, x comma y comma z, okay, such that satisfy this particular condition. Let this come there for this satisfying for where a, b, c and r are constants. Okay, are constants. Okay, and that set of all the points will give you this sphere. That is the set of all the points on the surfaces. That's what you have to understand. Okay, so set of all the points x comma y comma z for some a, b, c and r, if those x comma y comma z satisfies this equation, and definitely that will give you the surface points on this particular geometrical picture. What we call is the sphere. That's what we have to understand. Okay, this is a particular case where a, b, c is a center, x comma y comma z or the points on the surface, or is the constant distance. Okay, now what is the general form of the sphere equation? The general form of the sphere equation is this. General form of this sphere equation is this. Okay, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals 0. Okay, so this is a general equation. Look at this. This is the sphere. So again, it's not a circle, although it is looking like a sphere. Now I have to make it seeing like a sphere, then only it would be giving you some meaning there. I mean, right now it is looking like, am I correct? So this is a sphere where the center is minus u minus v minus w, and the set of points are x comma y comma z which are on the surfaces of this sphere. Then the set of points x comma y comma z which satisfy this particular equation, okay, is called the general form of the sphere equation. Okay, definitely this equation, that is set of points which satisfies this particular mathematical structure, definitely will give you points on the surface. Okay, and that's points on the surface, we call it as a sphere. Okay, so what it would be, the center would be minus u minus v minus w. Look at that in this particular sphere, minus u minus v minus w, that is the center, x comma y comma z, or the variable points on this sphere. Okay, then if that is the case, what would be the radius here? Okay, suppose the radius I am taking here as some r. You suppose I am taking here, this is r, that is from this place to this distance, constant distance from the center to on the surface points. If it is equal to r, then the radius is given by square root of u square plus v square plus w square minus d, and definitely this would be equal to r, not r square, r, because you are taking square root. Okay, so you understand that the constant distance for this general equation is that u square plus v square plus w square minus d, take the square root, that is the constant distance from the center on the surface points. Okay, so as far as sphere is concerned, these two things that you have to understand. The first one is about the particular case where the center would be a, b, c and r is r, and then in the general case where minus u minus v minus w are the center and the radius, that is the constant distance, is square root of u square plus v square plus w square minus d, then if that is the case, definitely this would be the general equation of a sphere. Okay, so that's what you have to understand. Now let me take one problem. Okay, then we will discuss that. I would like to take one problem. Let it come in a viewable space, then only it is easy to discuss. So the viewable space I will take there, center. Okay, still it is not viewable, am I correct? So I will minimize. If I minimize, too much of minimize will not helpful for us. So let me take that here. I will take this here. Now okay, now what is given there is that find the radius and center of the sphere. Okay, so I already told you that the general equation of the sphere is this one: x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals 0. Now look at that, this particular equation, that the equation given to us is of the form x square plus y square plus z square plus 2ux plus 2vw dot dot dot, like that. So this is what the general equation of a sphere, am I correct? This is a particular case given to us. So what we have to find, the center and also the center and radius of the sphere, that's what we have to find out. Okay, center and the radius of the sphere we have to find out. Now take this equation. Now what's the general equation of the sphere? General equation of the sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals 0. This is the central general equation of the sphere, that I am taking as equation number 1. I am taking equation number 1. So from the given equation, from this particular given equation, you take this. I am writing the given equation in this general form, like, okay. So how can we write this? X square I have written, y square I have written, z square I have written. But instead of minus 2 into x, I have written as 2 into minus 1 into x. Yes, without loss of generality, we can write this minus 2x like this. In order to get u v w, I am doing this. Okay, so 2 into minus 1 into x plus, without loss of generality, 4, I can write it as 2 into 2y plus, instead of minus 6 z, I can write it as plus 2 into minus 3 into x minus 2 equals 0. I am bringing this to this side. I will get minus 2 equal to 0. Why I am writing this? In order to bring in this general form. The general form, we have this. Am I correct? Now we already know that. What we know already is that look at that, if this is the general equation, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0, then the center is minus u minus v minus w. Okay, and the radius is square root of u square v square w square minus d. This minus d, that will give you radius. So in order to bring that radius and center only, I have written the given equation like this. Now if we written like this, we can say what is u, what is v, what is w. Am I correct? So if the general equation is 1, then the center is minus u minus v minus w. But in this case, in the particular case where the problem is given to us, in the place of u we have minus 1, in the place of v we have 2, in the place of w we have minus 3. Am I correct? So if you substitute those values here, minus 1 into minus u, 1 you will get, 2 you will get minus, here 2, so we'll get minus 2, here minus 3 into minus plus 3 you will get. Therefore the center of the particular sphere given to us is 1 minus 2 3. Okay, in the similar way, you must note that here the radius is given by the formula square root of u square plus v square plus w square minus d equals r. So we can get the radius also, square root of u square plus v square plus w square minus d. Here you will have here 1 square plus minus 2 square plus 3 square plus the d is what here, minus into, here minus into minus 2, that's plus 2. Okay, so if you add all of them, what will get, 1 plus 4, 1 plus 4, 1 plus 4 equals 5, 5 plus 2 7, 7 plus 9 16. So square root of 16 is equal to 4. Square root of 16 is equal to 4. Am I correct? And that's why we can get the center as well as the radius for the given sphere. Okay, therefore if this is the sphere, I mean this is the sphere, x square plus y square plus 2z square minus 2x plus 4y minus 6z equals to 2, then the center of this particular sphere must be 1 minus 2 3, and the radius of this particular sphere must be where is that? Yeah, 4. Okay, so that's how we can understand about the different different equations of the sphere, and also some problems we have discussed just before. Okay, so this is what, so you play this video again and again, then you will understand what I am saying to you. So the thing is that you have to play it again and again, then only you will understand that. Otherwise if you don't play, you cannot understand. Now come to next, the straight line equation. Okay, the straight line equation, let me minimize. Yeah, now it's okay. Now this is what straight line, how we are getting a straight line in geometry. Okay, in many ways we can get the straight line. Okay, in many ways we can get the straight line. Take for example here, this is one plane, P1 in blue color is one plane, P1 I have written, and in red color we have another plane, that is P2 I have taken. If they are intersecting one another, what we will get, this area dotted line will give us a straight line. Definitely there is no doubt at all. Am I correct? This dotted line will give you a straight line. Dotted line will give us a straight line. So a straight line can be get by intersection of the two planes. Okay, but we already know that the equation of the plane is ax plus by plus cz plus d equal to 0. Suppose this red color plane is this equation, and now look at that, very clear for you. Yes, and what is that? Lx plus my plus nz plus 0, not 0 o, is equal to 0 is the another plane, the blue color plane. Okay, this is red color plane, ax plus by plus cz plus d equals 0. And then the another plane, this blue color plane, is lx plus my plus nz plus o equals 0. These are the equations of the plane. We know what is the equation of a plane, am I correct? Because this is what, as I said just before, the set of points which satisfies this particular equation will give you this red color plane. Similarly, the set of points x comma y comma z such that this satisfies will give you this plane. Okay, I mean the points on the surface points on the particular geometrical figure. So this we can write it as ax plus by plus cz plus d equals 0. Okay, then this side we are writing lx plus mi plus nz plus 0 plus o equals 0. So usually instead of writing this way, we can write this way, no wrong at all, but we are writing in this particular way. Okay, so this is one of the a straight line equation. That's what you have to understand. Okay, we are looking at the equation of the straight line. Okay, so the one of the straight line equation is this. The basis is the intersection of the two planes. Intersection of the two planes. That's what you have to understand. Now look at that. This plane and this plane, the intersection is a line, and that is represented like this. The another form is the symmetrical form, we say. Okay, what we say is that what? Symmetrical form. So how we are getting this symmetrical form? That's what we have to understand. So first equation is over of the straight line equation, and now it is second equation, a straight line equation. That's what we are seeing now. That's called symmetrical form of the straight line. That's what you have to understand. Symmetrical form of the straight line. Okay, that's very important that you have to understand. Symmetrical form of a straight line. How it is get? Now let us take this particular this is OX axis, this is OY axis, this is OZ axis. There are three axes, and this is origin. Okay, this is the origin. This is OX axis, OY axis is the origin, OYZ axis. On this particular what is that, three-dimensional space, I am taking a point here on this particular line, where a is a point, x1, y1, z1, and p is a variable point on this line, p x comma y comma z. That means any one point on this particular straight line I am taking, and that point is x comma y comma z. Okay, so here also x comma y comma z, here also x comma y comma z, here also x comma y comma z, here also, here also, here also, but this is a particular point, x1 comma y1 comma z1. Okay, that is what this particular point, and this is what variable point. Now suppose that it will have its own it will has its own direction cosine, am I right? So direction cosine of this line I am taking as L comma M comma N, L M N. That is the direction cosine of this particular line with respect to this axis and this axis and this axis. And you join that, the base is M, and join with that parallel to OY plane. Okay, all this we can do like that. Okay, now what is the symmetrical form of this straight line? This straight line is from geometrical theory. We have x minus x1 by L equals y minus y1 by M equals z minus z1 by N equals R. Okay, this is what the general form of symmetrical form of a straight line. That's very important. Okay, so symmetrical form of a straight line, that's very important. Symmetrical form of what? Of a straight line. Straight line. Symmetrical form of a straight line. We can underline it. Okay, so x minus x1 by L equals y minus y1 by m equals z minus z1 by n equals r. This is what we call symmetrical form of a straight line, where x1, y1, z1 are any point on the straight line. L, m, n are the direction cosines. And what is this r? I have put all these ratios are equal to r. Am I correct? That r is nothing but the distance between this point A, particular point A, and to this particular point P. That's what you have to understand. Okay, so we can extend this line this direction also. That's what you have to understand. Now we can extend this point this direction, no problem at all. Similarly, we can extend that direction. So this is what we say the symmetrical form of a straight line. Now from this we'll get a point. Am I correct? So you take the first ratio and this r, what you'll get x would be equal to x1 plus lr. That's what we have. And you take this ratio and this r, you will have that y1 plus mr you will get. If you take last ratio on this r, you will get z is equal to z1 plus nr. So these are some of the points on this line. That's what we have to understand. Some of the points on this line, we will have x1 plus lr, comma y1 plus mr, comma z1 plus nr. This is some of the common points there. Okay, that's what we have to understand. Okay, now let us take so this is some of the point on this particular line. That's what you have to understand. Okay, so now the third form of the equation is called the line joining of the 2 points. Are we know that when the 2 points are there in a straight line, when there are 2 points on the straight line, we will have another form of straight line equation. Okay, when we are taking 2 points on the straight line, we will have another form of a straight line. That is this one. Suppose this is a straight line. P and Q are any 2 points. Let P be x1, y1, z1, and Q be x2, y2, z2. Okay, then the third form of the equation is given by x minus x1 divided by x1 minus, sorry, here x2, not x, and here we should have, right place will be rashing, and we have to write 2, and it's not 1, that is 2. Okay, right. Now look at that. We will have the equation of a straight line, joining the 2 points P and Q. We can write as x minus x1 by x2 minus x1 equals y minus y1 divided by y2 minus y1 equals z minus z1 divided by z2 minus z1. So this is the third form of the straight line equation. Okay, so this is a way we can understand the straight line equations there. Okay, now look at that. Okay, so this is what we studied just now. Different way we can write. That's what we have discussed. Okay, we will discuss one by one now. Now the intersection form of the straight line is ax plus by plus cz plus d equals 0 equals lx plus my plus nez plus o. That is the intersection of the 2 planes, that particular form. Second form is symmetrical form. That form is that x minus x1 divided by L equals y minus y1 divided by m plus z minus z1 divided by n equals r. And here what is x1, y1, z1, lmn and r you should know. And the third one, we are having a new equation of joining the 2 points P and Q, such that x minus x1 divided by x2 minus x1 equals y minus y1 divided by y2 minus y1 equals z minus z1 divided by z2 minus z1. Therefore, there are three forms of straight line equations. Okay, that's what you have to understand. Now, after understanding straight line, we are coming to the cone. Okay, the general form of a cone. That's what we are interested in. Now look at that. What you are seeing on the picture, this geometrical picture, we call it as a cone. Okay, how this cone comes, you have to how this cone comes here. The set of all the points x comma y comma z. Okay, x comma y comma z, and for some constants a, b, c, f, g, h, if that set of points satisfies this equation, and that will give you all the points on the surfaces. Okay, on the surfaces, that's what you have to understand. These are surfaces. On these surfaces you have lot of points. What are the points? Are the set of points which satisfy this particular condition. Okay, so take for example x comma y comma z, set of all points satisfying this particular equation should come here. Okay, inside the set bracket. So definitely we'll have some of the points. Am I correct? If you plot these 3 points on the 3-dimensional picture, you will have your points on this surface of the cone. Okay, that's what you have to understand. Where a, b, c, f, g, h are some constants. So for different constants, you will have different type of cones. But the set of all the points x comma y comma z such that this satisfies this particular condition definitely will give you a cone. I mean, not a cone, the set of points that if you plot on the 3-dimensional space, you will get a picture like this. Okay, and this picture we name as a cone. Okay, so other things that you have to understand about this picture is this particular point we call it as a vertex, and this angle, a constant angle between this generator and this line, slanted line, we call it as this. I think this is an axis. I think so. This is only a generator. I think so. Okay, so we have to change that. This I think that this is, we can take this as a generator. I think so. Okay, but this is what we call an axis. Yes, now it's okay, right? Now look at that here, and this we call it as a base curve, and all the points here we call it as a surface. Okay, that's what you have to understand. Those are called a surface. That's very important thing that you have to understand here. These are the surfaces. This is 3-dimensional. That's what you have to understand. 3-dimensional, we have to give like this, then only we'll have some meaning for that. Okay, so these are the surfaces, this and this, everything. This is a semi-vertical angle, this is a constant angle all through this. Okay, between this generator and the axis. This is called what? Base. It will be a circle definitely, and the O is called a fixed point. Okay, so now we have to understand that this particular cone is nothing but the intersection of this curve and this generator. Intersection of this curve and this generator. Okay, so we will have definitely every cone will have the 2 equation. One is connected to the curve, base curve. The another one is about this particular generator, and that equation is this, and this base curve is this. So intersection of the base curve and the generator will give you a wonderful picture like this. and how that picture, how that three-dimensional picture comes from this equation. Okay, so this is the equation. I mean the set of points as comma y comma z, which satisfies. If you project this on the three-dimensional space, you will get the picture like this. That we call it as a cone. Okay, so intersection of this generator and this base curve definitely will give you a cone. That's what you have to understand. Now, after knowing that, let us have as a last point here we are discussing is about the equation of a cylinder. Okay, equation of the cylinder. We know that, we don't know that, or we must note that here. We'll go first here, then afterward we'll understand that. Okay. No, okay, before that we'll discuss. That's the best. That's Indian way of teaching there. Yeah, am I correct? Okay, Indian way of teaching. Now look at that. This is a parallel line and this is a curve. Am I correct? And this is called guiding curve. This is called a generator. So the intersection of the generator, okay, straight line, and a guiding curve f of x comma y comma z equals 0, that will give you a picture on the three-dimensional like this. Okay, all the points on this, you will get a three-dimensional view you have to get. Therefore I am drawing the three lines so that we'll get a three-dimensional way of the picture. Otherwise it will look like a two-dimensional. Okay, very interesting. Now all this the surface points are the points which are the intersection of this guiding curve and the generator. That is what the intersection of this guiding curve and this generator also, which involves this axis line also. Okay, this axis line also. So let us make the derivation of the equation of a cylinder for the time being. Okay, right now let us discuss about how can we derive the equations of the cylinder for the time being. Okay, now look at this. This is what you are seeing. Whether in your cell phone you can see this or not, I don't know. That is why the problem comes. Now how we'll derive that particular equation. Okay, now the generator passes through the point x1, y1, z1. I mean, you look at the picture here. This is a surface point. Therefore, definitely it will go on a generator. It will lie on a generator x1, y1, z1. Okay. Therefore, we can have the equation, straight line equations, as we discussed just before. X minus x1 by L equals y minus y1 by m equals z minus z1 by n equals k. Definitely, because a generator is a straight line. So this is a point on the surface. The surface is obtained by this generator rotating this axis. Okay, revolution of that generator towards the axis will give you the surface. Therefore the point lying on this implies the points lying on the generator. So we'll have x minus x1 by L equals y minus y1 by m equals z minus z1 by n equals k. Also you must note that this particular straight line equation passes through the curve also. Look at that. Yes, see this guiding curve, it passes through the straight line. Am I correct? So this particular line should pass through this particular guiding curve also. Therefore it has to satisfy that equation also. Okay, so from this particular point we will have that if you take k here, first ratio, last one, you will get the first point. If you take this ratio, last point, you will get the second point. If you take the last ratio on this point, will get the third point. So definitely these 3 points will satisfy this guiding curve also. So guiding curve in our case is f of x comma y comma z equals 0. That form will come there. That's why we have written like this. Okay, now we are taking this equation number 2. Not only that, that particular point passes through the another equations. Another equation is the what? Yeah, straight line equation also, or a plane equation. So a into ax plus by plus c z equals 0. Okay, so that's what this particular equation. So this particular point should satisfy this equation also, because the base curve is the intersection of a plane and the curve, so that should satisfy this condition also. So from equation number 2 and 3, if we eliminate k, okay, if we eliminate k from equation number 2 and 3, we will get the equation of the form pi of x1 y1 z1. Pi of x1 y1 z1 we will have, okay, equals 0. Such an equation will get, and this equation is the equation of this cylinder. So equation of the cylinder is pi of x1 y1 z1, where p is the point, x1 y1 z1. So it's a particular point, we have this particular equation. But this particular point not only lying on the surfaces, it is a variable point. All these point, here point, here point, here point, okay, so all this particular point makes this cylinder surface, therefore this is a variable. So instead of writing x1 y1 z1, we can write the general form of the cylinder as pi of x comma y comma z. So the set of all the points x comma y comma z under this particular equation will give you a three-dimensional picture like this, and this we call it as a cylinder. Okay, so so far we have discussed much on the analytical geometry. Am I correct? Analytical geometry we discussed much today. About a sphere, we discussed about that, different equations, and also some problems we did there. Then afterwards, straight line equation we came here. Straight line equation, intersection of the two planes is one equation, the another one is symmetrical form, third one is the joining of the 2 points, that equation we have. Then afterwards, cone equation we got. It is an intersection of a what we call generator on the guiding curve, and the cylinder is also the intersection of the generator on the guiding curve, and we got that the equation of the cylinder is pi of x comma y comma z equals 0. So with that today we have to come, and we must have that. Today we discussed about much on that. Am I right? So in geometry, what we discussed today was very useful, I think so, for you. Okay, I thought that this definitely would be very useful for you. And in the another video I would be giving you some problems connected with all these things. Okay, so till then I have to say thank you to all of you for listening to me for the past nearly I think maybe 45 minutes, I think so, exactly don't know. So thank you very much, my friends. Thank you.